How do activation functions change for regression versus classification? Imagine you're trying to teach a computer to tell the difference between a cat and a dog, or to predict the temperature outside tomorrow. The way you set up the computer's brain, called a neural network, depends on what you want it to do. That's where activation functions come into play. They are like the switches that help the network decide how to pass information from one layer to the next. But did you know that these switches work differently depending on whether you're solving a problem that involves numbers or categories? Let's explore how activation functions change when working on regression or classification tasks. In a regression problem, where the goal is to predict a number like the price of a house or the speed of a car, the final layer of the neural network usually uses a linear activation function. This means it just passes the raw output without changing it. Why? Because the output can be any real number, positive or negative, and we want the network to have the freedom to produce any value on the number line. The hidden layers in the network often use nonlinear activation functions like ReLU, which stands for Rectified Linear Unit. ReLU helps the network learn complex patterns by turning on only when the input is positive, making it easier for the network to model real-world data. Now, when it comes to classification, which involves sorting things into categories like cat or dog or spam and not spam, the activation functions in the output layer change. For binary classification, where there are only two options, the sigmoid activation function is used. It squashes the output into a number between 0 and 1, which can be interpreted as the probability of belonging to a particular class. Think of it as a yes or no switch that gives you a clear answer. For problems with more than two categories, the Softmax activation function is the go-to. It takes all the raw scores from the last layer and converts them into probabilities that add up to 1, making it easy to see which class the network thinks is most likely. Hidden layers in classification models also use nonlinear activation functions like ReLU or its variants. These functions help the network learn complex decision boundaries, making it better at distinguishing between different categories. The key difference is that, in regression, the focus is on producing a continuous number, so the output layer stays linear. In classification, the goal is to produce probabilities, so the output layer uses Sigmoid or Softmax depending on the number of classes. Understanding these differences is important because it influences how we train the network and what kind of loss functions we use. For regression, we often use mean squared error, which measures how far off our predictions are from actual values. For classification, cross-entropy loss is common, as it compares the predicted probabilities with the true labels. In applications like ChatGPT, DALL-E, or Midjourney, knowing which activation function to use helps the AI perform its tasks accurately. For example, language models like ChatGPT use Softmax in their output layer to predict the next word in a sentence, which is a classification task. Meanwhile, image generation models that predict continuous features might use linear activations to produce realistic images. Choosing the right activation function ensures that the neural network learns effectively and produces trustworthy results. It's like selecting the right tool for the job, whether you need a precise number or a clear category. So next time you see a neural network in action, remember that its activation functions are working behind the scenes, changing to fit the task at hand.